Namaste students. Today we will discuss 2026 JEE session 1. 22 January shift 1 physics paper solution. Okay, let us start. Question 1. A particle is projected at an angle of 60 degree with the ground. When projectile makes an angle 45 degree with the horizontal, its speed becomes 20 meter per second. Then initial velocity is particle is projected at an angle of 60 degree and projectile makes an angle 45 degree with horizontal. Its speed becomes 20 meter per second. Then we have to find its initial velocity. Okay. In this case, particle is projected like this. Initial speed is u and initial angle means projection angle is given as theta 60 degree. So when its angle with horizontal is 45, let us say that its point is like this. So this angle is become 45 degree. At that time its speed is 20 meter per second. Then we have to calculate for theta. So in projectile we know that the horizontal component of a projectile is remain constant throughout the motion. So at this time the horizontal component will be v cos 45 and here horizontal component of a projectile is u cos 60. So u cos 60 and v cos 45 at all time will be same. So we can say that u cos 60 is equal to v cos 45. So u cos 60 is equal to 1 by 2. V is given as 20 meter per second. When at angle at 45 degree. So 20 into cos 45 is equal to 1 by 2. So u will be root 20 into 2 by root 2. So root 2 into root 2. So 20 root 2 meter per second. 20 root 2. One of easy question from motion in plane. Next, from electrostat, find electric field intensity E at center of circle. We have to find electric field intensity at the circle due to these four charges. There are three charges with sign positive and one with negative. So we can see that plus q and plus q are at same distance from the center. So they will both cancel out each electric field. So this electric field in direction and this will be in this direction. So these two electric field will be cancel out each other. Now here minus q charge and here is plus q charge. So electric field due to plus q charge will be in direction in this direction, and for minus q charge electric field will be in this direction. So let us say electric field is E due to individual charge. So we can say E plus is equal to aq by distance from this is given as capital R. So we can say R square, and E minus is also aq by R. So net electric field is 2 times of E plus plus E minus. So 2 times of aq by R. This is our net electric field. But here answer are given in a vector form. This is the net magnitude of electric field, and we have to calculate for a vector form. So we can see that this is angle 30 and this is also 30. If this angle is 30 degree, then this angle will also be 30 degree. So here net electric field is look like that E net make angle 30 degree with negative x axis. Here is positive x, positive y and negative y. So we have to break E net into component of Ey and Ex. So we can say that this component is Ex and this component is Ey. So Ex will be Ex is equal to E net cos 30, where E net is equal to 2kq upon r square. Cos 30 is equal to root 3 by 2 to cut. So root 3 kq by r square I kept, but here electric field in x direction is negative, so we can say that minus root 3 kq by r square into I cap. Let us see question 1. Same to same for electric field in y direction, we can say that Ey is equal to E net sin 30. E net sin 30. So net electric field is 2kq upon r square into sin 30 is equal to 1 by 2 to cut. So kq by r square in check. Okay. So this is Ey. So check the option. Ex is negative and Ey is positive. In all of the questions, electric field in y x direction is negative. Root 3 kq by r square I can plus kq by r square j can. Okay. So our answer will be second. So easiest question from electrostats. Some vector are involved in this. Third question. As shown in the figure, 6 rods of same geometry are connected and maintained at a temperatures 100 degrees Celsius and 40 degrees Celsius. The temperature at points A and B are. So we have to find the temperature of point A and temperature of point B. Here all rods have same length and same area. So they are identical. Thermal properties of metal. Question from thermal conduction. Okay. Thermal conductivity is K, 3K, 3K, and 3. So first of all, we have to convert these all rods into form of resistance. After finding current in whole circuit, then we will be able to give answer of temperature of point A and B. Okay. So we know that resistance is equal to L upon K. Okay. So let us assume one of the resistors from any of the rod. So we can say that let us say resistance of this Y is R. Then we can say that L upon 3K A is considered as R. Then if resistance of this wire is R, then this wire is also R. Then for this, so let us say R dash. So R dash will become L upon K. So R dash by R is equal to L upon K by L upon 3Ka. So L upon K cut. So this will become 3. So we can say that R dash is equal to 3R. So if we assume that this is of resistance R, then this will become 3R, this will become 3R. So this will become 3R2 and this will be R. So from the diagram of thermal conductivity, we will change it in equivalent resistance. So after that, we will be easily able to find current. Okay, so let us convert this diagram into resistance. Okay, here are R, 3R, here also 3R, and here R. Okay, so let us say, okay, so equivalent of this will become 6R, this will be 2R. So now 2R and 6R are in parallel. So let us say that this is R1. So R1 will become 6R into 2R divided by 6 plus 2 is equal to 8. R cut 2 into 4, 2 into 3. So R1 becomes 3 by 2R. So 3 by 2R and 3R and R are in series. So R equivalent. R equivalent will be R plus equivalent of this is R1 and R1 is a 3 by 2 plus 3R. Okay. So 3R plus R, 4R plus 3 by 2R. So now 4 plus 2, 8. 4 into 2, 8. 8 plus 3 is equal to 11 by 2R. This is R equivalent. So R equivalent of this whole circuit is comes out to be 11 by 12. So from now we can calculate current. So for current we can say that delta T by R equivalent. Delta T is equal to 100 minus 40. So 60 degrees Celsius divided by R equivalent is equal to 11 by 2R. So I will become 120 by 11R. Let us say 11. So it means that current will be passing through this whole circuit will be I. Here will be current will be converted in other values. Okay. So first of all, we have to find the temperature of point A. For that, consider the resistance this. Let us name these all points. This is 100 degrees Celsius. This is point A. This is point B. And let us say this is at 40 degrees Celsius. So consider the resistance of R. Here I current is passing. Temperature is 100 degrees Celsius and temperature at point A we have to find. So let us set TA. So from this diagram we can say that I is equal to delta T by R. Okay, for this. So I is equal to 120 upon 11R is equal to delta T is equal to 100 minus T upon R. So R cut. So 120 by 11 is equal to 100 minus T. So TA will become 100 minus 120 by 11. So 11 into 100, 11, 0 minus 120 divided by 11. So for calculation, let us use a calculator. So 120 divided by 11. So 89.09 degrees Celsius. So temperature at point A is 89. Okay. From options we got answer, but let us find a TB. That how we can find TB2. Okay. So for that, here is also current I is passing. I current temperature at point B. We have to find. Temperature of one point is given, resistance is 3, then we can find TB easily. So for that let us insert page, change background. Okay. So here is TB, here is 40 degrees Celsius, resistance is 3, current is passing I. So we can say that I is equal to delta T by 3. Current is 120 by 11R. 120 by 11R is equal to delta T is equal to TB minus 40 upon 3R. RR will be cut. 3 into 120 upon 11 is equal to TB minus 40. So you can say that TB is equal to 120 into 3 by 11 plus 40. 120 into 3. 360 plus 11 into 4, 44 into 0 upon 11. This will become 4 plus 3, 7, 7 plus 1, 800 divided by 11. So TB will come out to be 800 divided by 11. So 72.72 degrees Celsius. Let us check option. Okay. Near about answer is as 73 degrees Celsius. Okay, you can see that thermal conduction's formula questions can be easily solved from current electricities. Okay. Next question. A convex lens of focal length 5 cm and a concave lens of focal length 4 cm are placed in contact and a point object is placed at 10 cm from system. In this arrangement, magnification is M1. Now keeping system as it is concave lens is moved 1 cm away and now magnification becomes M2. Find M1 by M2. Okay, here is the question from optics. Convex lens of focal length 5 cm, let us say f1. A concave lens of focal length 4 cm, let us say f2. Are placed in contact and a point object is placed at 10 cm away. Let us say this is the object distance u from the system. In this arrangement, magnification is m1. Okay. Now, keeping the system as it is a concave lens is moved 1 cm away and now magnification becomes m. Then find the ratio of m1 by m. Okay, this question looks like little lengthy. So let us calculate one by one. So in condition 1, there are convex lens of focal length f1 and another lens of focal length f2. Concave lens is given. They are both placed with contact with each other. Now, object, let us say object O is placed at u is equal to minus 10 cm from the system. And in this arrangement, the magnification is m1. We don't know. We have to find m1. And in second condition, if a concave lens is move further away by 1 cm away, then magnification becomes m2. So second condition will look like this. This is the convex lens and concave lens is moved by 1 cm. So from this configuration, object distance remains same. Then magnification in second case will become m2. So we have to find ratio of m1 by m2. Hope you will understand the question. Okay, now we will solve it step by step. First of all, we will find m1. Okay, what will be the value of m1? Here, both the lenses are in contact, so we can use formula of F equivalent. F equivalent is equal to 1 upon f1 plus 1 upon f2. F1 is considered as a value of f1 is 5 cm and value of f2 is equal to minus 4 cm. So f1 is equal to 5 plus f2 is equal to minus 4. So 4 minus 5 upon 5 into 4 F equivalent. So F equivalent is equal to 20 upon minus 1. So F equivalent will become minus 20 centimeter. From this we have to calculate for magnification. So we know that magnification in term of F equivalent and object. So magnification is F upon F plus U. For condition 1, F is said to be M1. F is considered as minus 20. F is again minus 20 plus U is considered as minus 10. Okay. For the simplification, minus 20 upon minus minus plus minus 30. 0 0 cut minus minus cancel. So 2 by 3. M1 is 2 by 3. Let us say equation 1. Here magnification is a positive, so image will be virtual and erect. Okay. Now moving from situation 1 to situation 2, here we cannot directly use F equivalent formula because there are separation between two lines, and if there are separation between two lines, we cannot use this equivalent formula directly. So for that, we can use step by step that this object's image will form by this lens. After forming first image, the first image will become a object for this lens, and after a second reflection, this lens will form a final image. And from that, we will use a total magnification, and after that, we will put in M2, and after we will get the ratio. So first of all, we have to find that from reflection of the from this lens, what will be the value of image distance. Then image distance will become object for this, and further we will calculate the total magnification due to this system. So for second condition, u is equal to 10 cm, f1 is same as 5 cm, f2 is same as minus 4 cm. So u is given, f1 is given, so we will calculate for v. So 1 upon f1 is equal to 1 upon v1 minus 1 upon u. So 1 upon f1 for 1 upon v1, 1 upon v1 is equal to 1 upon f1 plus 1 upon u. So f1 is 5 plus u is equal to minus 10. So 1 upon v1 is equal to 10 minus 5 upon 50. So v1 become 50 upon 10 minus 5, 10. So v1 become 10 centimeter. Okay, v1 will be 10 centimeter from this lens. So from this lens, 10 centimeter will looks like this. Let us say image 1, and distance between this is 10 centimeter. Okay, for this lens, this first image will behave as an object for this lens. So image distance, let us say u2 is equal to, we have to find. So this is 1 centimeter, and 10 centimeter subtract 1 centimeter from 10 centimeter, we will get u2. So u2 will be 10 minus 1, so 9 centimeter. Okay, and now this image for this lens is behaves as object, and object is placed right side from this lens. So u will be considered as a positive. So for this lens, focal length is given, object distance is given, then we will find a final image distance from this lens. So 1 upon f2 is equal to 1 upon v2 minus 1 upon u2. So f2 and u2 is given. So for 1 upon v2, we can write 1 upon f2 plus 1 upon u2. Options are worse with solution. 1 upon v2, 1 upon f2, 1 upon f2 is equal to minus 4 plus u2. u2 is 9 centimeter. From this, minus 9 plus 4 upon 4 into 9. So minus 5 upon 9 into 4, 36. So v2 will become 36 by 5, but negative. Okay. So we have v2 and u2 and v1 also. Okay, so let us say that magnification from this lens and magnification from this lens, from convex lens, let us say m dash, then m dash will become v1 by u1. So v1 is 10 centimeter and u1 is 10 centimeter also. So this will become 1. M dash is equal to 1. From convex concave lens, let us find magnification due to concave lens. So concave lens, let us say magnification is m dash, then m dash will become v2 by u2. So v2 comes to be minus 36 by 5 into u2 of 9. So 9 into 4, so minus 4 by 5 is m2. So m dash and m double dash is the magnification due to these both lenses, and if we want to find the total magnification due to this system, we can directly multiplication of these two, m dash and m double dash. So for that, let us insert page and change paper background. Okay. So m2 is considered as m dash into m double dash. We know that. Okay. So m dash is 1 and m double dash is equal to minus 4 by 5. So 1 into minus 4 by 5. So minus 4 by 5. This is m2. Now m1 by m2. So m1 is 2 by 3. 2 by 3 divided by m2. Alright, okay, here is m2. m2 is minus 4 by 5. So 2 by 4 into 3 by 5. So minus 10 by 12. So m1 by m2 is equal to minus 5 by 6. So let us, okay, magnification becomes 5 by 6. 5 by 6. Okay. Our answer is 5 by 6. So little lengthy question. We have to calculate 4 or 5 quantities, means 4 or 5 values. In all these questions, we simply use a formula of magnification and lens maker formula. Nothing more. Next question number 5. Escape velocity from a planet of radius r and density rho is given as 10 km per second. Okay. Find the escape velocity from the planet of radius r by 10 and density rho by 10. In this question, there are two planets. Let us collect data first, and then we will simplify and will think that what formula and how to will calculate. So for planet 1, radius is r and let us say density is rho. First, and escape speed VE1 is 10 km per second. So let us say 10 into 10 raised to 3. So 10 raised to 4 meter per second. For second planet, radius is r by 10 and density is rho by 10. Then what will be the escape speed from this planet? Let us say r1, rho2. Sorry, this is r2 and rho1 is equal to rho. Okay, so we have to find escape speed in the form of radiation density. We know the formula of escape speed. Then escape speed is written as 2gm by re. Sorry, this is for Earth. So general formula of 2gm over r, where m is the mass of planet and r is the radius of that planet. So here mass and radius, mass is given in the form of density. So we have to eliminate mass and introduce density. So for that, 2g by r, mass can be written as density into volume. So further, volume can be written as 4 by 3 pi r1. So 4 into 2, 8 by 3 0 pi into r square. Here is simplest formula of escape velocity in the form of data given in question. So here for both the planet 8 by 3 g pi or r constant. Density and radius is changing. So we can say that velocity escape speed is proportional to rho into r square. So we have to find v2. So we can say that v2 divided by e ve1 is equal to rho 2 r2 square upon rho 1 r1 square. Put the data. Rho 2 is given as rho by 10 upon rho 1 is rho into r2 by r1 whole square. So we can say that r by 10 upon r whole square. So rho will be cut, r cut. So 1 by 10 into 1 by 100. This is v2 by v1. Okay, now ve2 upon v1 is given as 10 raised to 4 meter per second is equal to 1 upon under 1000. So ve2 will become 10 raised to 4 divided by 1000. So 10 raised to 4 upon this will become root of 100 is equal to 10 root 10. Okay, answer is in meter per second. Okay, 1 power unit cut. So 1000 divided by root 10. Okay, further we will simplify. We can say that 100 into 10 upon root 10. We can say that this is root 10. So 100 root 10 meter per second is the escape speed from second planet. Okay, our answer is third. Next one, figure show metal bridge. Initially, null point was achieved at a distance of 40 cm, where a resistance of 60 ohm is attached in parallel with the R2. Okay, here is R2. New balance point was achieved at 50 cm. Then find value of R1 and R2. Okay. So friends, here is another question from meter bridge. If you watch a previous video or a paper of 21st January second shift paper, there was also same type of question of meter bridge, but in that case we have to find balancing length, and in this question we have to find resistance. So you can see that some questions are repeatedly asked in generally by NT. So my suggestion is that you have to solve the previous shift paper. Okay. So in this meter bridge, initially null point was achieved at a distance of 40 cm. Means in first case null point is x1 and x1 is considered as 40 cm from this point. Okay. When R1 and R2 are connected, when a resistance of 60 ohm is attached in parallel with R2, when 60 ohm is combined with R2 in parallel, new balance point was achieved at 50 cm. Okay, so let us say this is the balance point x2. Then we have to find R1 and R2. So we know that in balancing condition we can write R1 by x1 is equal to R2 by 100 minus x1, because length of meter bridge wire is 1 meter or 100 centimeter. So R1 by R2 is equal to x1 upon 100 minus x1. Value of x1 is in first case is given as 40 upon 100 minus 40. So 40 by 60. So 2 by 3 is R1 by R2. Let us say value 1. Okay. Now in second condition, 16 ohm is attached in parallel with R2. And new balance point will be achieved at 50 cm. So in this arrangement, R1 is as it is, but 60 ohm resistance is connected with R2, and now balance point comes to be as x2 is equal to 50 centimeter. Okay, so let us say that equivalent of 16 and R2 can be written as let us say R3. So R3 will become R2 into 16 upon 16 plus R2. Okay, and now equivalent resistance of this branch is, let us say, R3. Now R1 by x2 is equal to R3 by this distance. So from balancing condition, we can write that R1 by x2 is equal to R3 by let us say 100 minus x2. 100 minus x2. Now R1 by R3 is equal to x2 by 100 minus x2. R1 is as it is. We can write R3 is equal to R2 into 16 divided by 16 plus R2 is equal to x2 is given as 50 centimeter. Then 100 minus 50 is also 50. 50 is equal to 1. So cross multiply further denominator will become into numerator. So this will become 16 plus R2 into R1 upon R2 into 16 is equal to 1. So cross multiplication 16 R1 plus R1 R2 is equal to 16 R2. So further simplification, let us 16 let's common R1 take common. R1 16 plus R2 is equal to 16 R2. So from now we can put value of R1 or R2 from this equation in this equation. Let us see equation 2. So from equation 1, R1 will become 2 by 3 of R2. So let us put value of R1 in this equation. So R1 is equal to 2 by 3 of R2 into 16 plus R2 is equal to 16 R2. Okay. So from multiplication R2 will be cut. So 16 plus R2 is equal to 16 into 3 by 2. 2 into 8. 8 into 3 is equal to 24. So R2 will become 24 minus 60 is equal to 8 ohm. So R2 will be 8 ohm. 8 ohm are given in two options. And now further simplify for R1. So put the data of R2 in this equation and we will get R1. So for that calculation, R1 by R2 is equal to 2 by 3. Then R1 becomes 2 by 3 into R2 is 8. So 16 by 3 ohm is the value of R1. And this is the option number 3. Okay. Next question from the semiconductor of logic gate. In the figure, the LED will grow for input of A, B, C, and D. 0 is low potential and 1 is high potential. Okay. Here are the combination of some logic gates. Here is LED, and we have to find that for which input from these 4 options the LED will be glowed. And in this question, there are data that 0 can be considered as a low potential and 1 is considered as a high potential. So, for LED to be glowed, this state will be compulsory can be in forward bias, and for this state to become forward bias, the output at this point should be 1 and output at this point should be 0. So we have to find that for input of A, B and C, D, the output at this point should be 0 and output at this point it should be 1. If there are no output from 1 or 0, then LED will be not glow, because for that condition that will be reverse bias. So we have to find that in which options the output from AB comes to be 1 and output from CD comes to be 0. So for this question we have to check one by one all questions, because this is the questions like hit and try. Okay, so let us start from option 1. That if input is 0 0 1 A, means value of A is 0 0 1 and 0, then what will be the output? So here is 0 0. So this is short circuited. So input at this point is 0, at this point 0. Okay, so inverse of 0 is 1. Inverse of 0 is 1. Now 1 1. This is AND gate. From AND gate we know that the output at this point will become 1. So output at this point will become 1. Okay, so 1 is come. Okay. So now for CD, this is 1, this is 0. This is our NOR gate. So for NOR gate, 1 plus 0 is equal to 1. Inverse of 1 is equal to 0. So here 0 output is come. So 1 and 0. 1 is higher potential, 0 is lower potential. So this diode will be in a forward bias, and for forward bias LED will be glow. So here it is answered. You can solve for these other questions too for verification. But our answer is 1. Next question from fluid mechanics. Okay, rotating fluids, specific topic. A closed tube filled with ideal gas is rotating with omega along the axis passing from end A. Find pressure at other end B. M is molar mass of the gas, and L is length of tube, and T is the temperature of gas. Okay, it is length of this tube. Okay, here is the gas is given, not the fluid. So this is the question. You can say that multiple concept like fluid and KTG or thermo. This type of PYQ is previously asked, but in that case, here are liquid is filled up with fluid. In this case, there are gas. So we have to apply multiple concept from KTG and thermo plus fluid. Okay. So we have to find pressure at point B. Okay, what will be the pressure at this point? Okay, so for that, let us draw diagram. This is point A and this is point B. Let us say that pressure at this point is P and pressure at that point is PB, and we have to calculate for PB. So for this, length of this tube is L. Here the gas is filled up. You can feel that when B comes away from the axis, the pressure will be increasing. So let us take one general point. Let us say that this is the small mass dm, length of this is dx, and distance from this is can be taken as x. So we take one small element of mass dm, thickness dx, and length from distance from this point is x. We can say that area of this tube is A. If here is pressure P, then here will be pressure will be P plus dP. Because from moving from axis to this point, pressure is continuously increasing due to rotational effect of the fluid or gas. So, due to this pressure and difference, the force will be F. So, we can say that F is acting in this direction and F plus dF is acting in this direction. So, this is a force F due to pressure difference, and we say that the dF force is greater and direction of dF will be in left side. So, some other force of same magnitude and direction opposite of dF will be acting on this small element, and that force is also rotational or due to circular motion. So, consider dF mass here. dF mass, dF force is acting toward this, and dF omega square x is acting on right side. Now this small element is not moving in this direction, so these two forces are balancing each other. So we can say that dF force is equal to dF into omega square x. So let us put value of dF. dF can be written, we know that the force is, pressure is equal to M upon area. So F can be written as pressure into area. So in this case, small dF force can be written as small pressure dP into area. And here dm mass can be written as density in small volume. Let us say that volume of this small element can be written as dV into omega square x. So dP into area, rho as it is, volume dV can be written as this is distance dx and area is a. So a into dx into omega square x. Okay. So a will be cut. So in this equation, dP will become rho omega square x into dx. That is equation 1. Now, other data that M is molar mass of the gas, length L is tube length, and T is the temperature of gas. So we have to find temperature. It could be in the terms of molar mass, temperature, R, omega, L, and P. So you can see that we have to introduce equation of R or M and T in the form of any density. So we have a formula that the pressure is equal to rho RT by M, when M is our molar mass, and in this question capital M is considered as a molar mass. So we can write that rho RT by M. Here M naught is considered as M. Generally we use a small capital M is a mass and M is molar mass. But in this case, M is considered as molar mass. Okay. So from this question, rho can be written as rho can be written as P into M upon RT. Let us see equation 2. Now put the value of density in this equation 1, and we will relate pressure with pressure and x with distance dx. So put the value of 2 in equation 1. We will get dP is equal to rho is equal to Pm by RT into omega square x into dx. Okay. So here is pressure. Change the pressure in left side and x is right side. So dP by P is equal to M RT omega square into x into d. Now here are the some terms like Laplace integration, that the right side changing is x and the left side changing in pressure. So we will integrate that when x is equal to 0, pressure at that point is P. When x is equal to 0, 0, pressure at this point is P. And when value of X become L, then pressure will become PV. Okay. So integration 1 upon P dP will become L and P. Limit can be written as PA into PV. And right side m omega square by RT is a constant, so we can say that m omega square RT is common. And integration of x dx can be considered as x square by 2, and limit is 0 to L. So we can write ln PV by PA is equal to m omega square RT L square by 2. Okay. So take log both sides. We will get PV by P into e raised to m omega square L square RT into 2. So PV will become PA e raised to m omega square L square upon 2 RT. Okay, now next the questions, options. PA e raised to m omega square L square. M omega square L square 2 RT. 2 RT m omega square L square 2 RT e PA. So option is matching is A. Okay, so you can see that this is the one of the good question from mixed concept. Okay, here gas is considered as a fluid, and you can see that answers are in exponential. So in this type of question there are some points where we have to there are some click. Okay, some concepts should be linked. Next question: for an ideal gas in reversible process, delta Q is equal to 0, volume becomes 8 times and temperature becomes 1/4 times the initial value. Okay, identify the gas. For ideal gas, reversible process, it means delta Q is equal to 0, and when delta Q is equal to 0, it means that process will be adiabatic or isotopic. So volume becomes 8 times and temperature becomes 1/4 times the initial value. Then identify the gas. Okay, which types of gas will be this? Okay, let us say case 1, case 2. In this case, let us changing in volume and temperature. So V1 can be considered as V, and temperature T1 can be considered as T. So V2 will become 8 times. So 8 times of V, and T2 will become T by 4. Okay. So we have to find which gas will be this. So for this, if we want to value of gamma for this gas, we will easily comment on the gas that which type of this gas will be. So first of all, we have to find gamma, and after that we will simplify. We will say that which gas is this. So for polytropic or adiabatic process, we can say that here is T and V are changing. We have equation that PV raised to gamma is equal to constant. But in this question, there are data of volume and T, temperature and volume. So we can say that PV raised to gamma minus 1 is equal to constant. Okay, we all know this. So from both data, we can say that T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. So initial temperature is T, V1 is V gamma minus 1, T2 is T by 4, and final volume is 8V into gamma minus 1. So TT cut. So 4V raised to gamma minus 1 is equal to 8V raised to gamma minus 1. Okay. So, 4, we can write v raised to gamma minus 1, or we can use a simple separate quantity v raised to gamma into v raised to minus 1 is equal to 8 v raised to gamma into 8 v raised to minus 1. So we can say that 4 v raised to gamma by v is equal to 8 v raised to gamma by 8. So v will be cut 8 into 4 is equal to 32 v raised to gamma is equal to 8 v raised to gamma. So 32 is equal to 8 v by v whole power gamma. V we cut, so 32 is equal to 8 raised to gamma. So from this we have to calculate for gamma. So for that, what can be written further? So 8 can be written as 2 raised to power 3 raised to gamma, and here 2 raised to power 5. So here you can say that 2 into 3 gamma is equal to 5. Sorry, 2 raised to 5. Here base are same, so we can say that 5 is equal to 3 by 3 into gamma. So we can say that gamma is equal to 5 by 3. Value of gamma is 5 by 3. So value of gamma is 5 by 3 is for the value of gamma 5 by 3 can be only for diatomic gas or not, and diatomic is only O2. 5 by 3 is equal to gamma. Gamma can be written as gamma can be written as f by 2 plus 1. So gamma is 5 by 3. So f by 2 plus 1. So 5 by 3 minus 1 is equal to f by 2. So 5 minus 3 is equal to 2 by 3 is equal to 2 by 3 is equal to f by 2. So f is equal to 4 by 3. I think we have made a mistake. Gamma is equal to f by 2 plus 1. 5 by 3 f by 3 plus 1 minus 1 f by 2. 2 by 3. Just a minute, friends. I think I don't remember the value of gamma for different cases. 5 is equal to 3 gamma and gamma is equal to 5 by 3. Gamma is 5 by 3 for monoatomic gas. And monoatomic gas in these options are only helium. So helium is the correct answer. Okay. Here we have to remember all the value of gamma for different gases. I didn't remember, so I recently checked and say that value of gamma is 5 by 3 for monoatomic gas. So we have to remember some things, some data in physics too. Okay. Next question. A simple pendulum with a bob of mass small m carrying a charge q is in equilibrium in presence of horizontal electric field E. Then tension in the thread is. Okay. Simple pendulum with a bob of mass small m carrying a charge q. This bob has mass m and charge q on it. In equilibrium presence of a horizontal electric field E, the tension in the thread. We have to calculate tension in this thread. So, electric field is in direction this. So, this bob will experience F in this direction, and this will act downward. So, from tension, this is theta. So, this is also theta. So, this will become T cos theta, and this will become T sin theta. Okay. From this equation, we can say that T sin theta is equal to F and T cos theta is equal to mg. We have to calculate for tension T. So for tension T, we don't have to eliminate this tension. So we can spare both sides and after that summation. So this will become T square sin square theta is equal to f square, and this equation can be written as T square cos square theta is equal to m square g square. So equation 1 and 2. Let us summation of this both equation. We will get T square sin square theta plus cos square theta is equal to f square plus m square g square. Sin square plus cos square theta is equal to 1, then t square will become f square plus m square g square. So t square is equal to f can be written as q square into t square plus m square g square. So t will become q square e square plus m square g square. So our option is 1 is correct answer. Next question. There is a glass sphere of a refractive index 1.5 on which a parallel beam of light falls. Find distance of final converging point of a final emergent ray from center of sphere. Radius of sphere is 50 centimeter. Okay. Refractive index of this spherical glass surface is 1.5. Radius of curvature of this spherical surface is 50 centimeter. Okay, here is the final distance of final converging point of final emergent ray. We have to find that when two rays are converge or emerge and meet at any point, that distance of that point from center. Okay, so from this we have a diagram like this that this is spherical surface. Okay, let us write here. I think this will acquire some space. Okay, this is the center. Now parallel ray are coming. Let us say this is the axis of a spherical surface. Now parallel ray are coming, so let us say that parallel ray are comes like this. Okay. So from this surface, they will bend toward a normal. Then they will be goes like this. Okay. And after this, they will be here. They are going toward a denser to rarer medium. So after they will be diverged. So this will become So we have to find that final distance of final converging point of a final emergent ray. These are final emergent ray. Why? This is incident ray, this is a reflecting ray, and these are two are emerging ray. So we have to find distance between center and converging point. Let us say point P. Okay, the distance x. What is the distance x? For that, consider that this is surface 1 and this is surface 2. Here are two reflections are formed in this one question, that from spherical surface 1 and from spherical surface 2. So we have to use two different cases of spherical surface and then find that distance from this point. Okay. So for spherical surface 1, for first surface. For first surface, we can say that u is equal to infinite. Radius of curvature is plus 50 centimeter, and we have to calculate v. And refractive index n is given as 1.5. So from this data, we can use a simple spherical surface formula. N2 by v minus n1 by u is equal to n2 minus n1 upon r. So n2 is 1.5, v we have to find, minus n1 is equal to 1, u is infinite, n2 is equal to 1.5, n1 is equal to 1, and the radius of curvature is equal to 50 centimeter. Okay. Now 1.5 by v, this will become infinite, 1 upon infinite is 0, is equal to 1.5 minus 1 is equal to 0.5 upon 50. So 1.5 by 0.5 into 50 is equal to v. So this is, can be said 3 into 50 is equal to 150 centimeter. This 150 centimeter is the distance from this point. Let us say A. From A to 150, and this is when these blue rays are converging at that point. Let us say that if we move this ray further away, then we will get that this point, let us say B, then distance from point A to B is given as V is equal to 150 centimeter. So you can say that from first surface the ray will become like this, but after reflecting from second surface, this will merge and walk in green direction. So this point is formed as image I1, and I1 image is the object for second surface, and final image I2 will be formed. Okay, so I1 is initial image and I2 is equal to final image, and I1 image formed by this surface can be considered as a object for second surface. So now for second surface, we have to calculate this distance. Okay, for this distance, radius of curvature is 50. So diameter of this sphere will be 100 centimeter, and distance of point B from A is 150, and this distance is 100. Then this distance should be 50 centimeter. So let us say U2. So U2 will become 150 minus 100. We can say that this diameter is 100 centimeter. I hope you will be understand this diagram. Diameter is 100 centimeter. So distance of V2 is equal to 50 centimeter. We consider this distance is U2 is equal to 50 centimeter because this direction is considered as positive and this direction is considered as negative because they are coming from left to right. Okay, so this is U2 of 50 centimeter for second surface. For second surface, radius of curvature will become minus 50 because all distance will be considered from this, let us say point C. So distance of this point is in negative direction, so R will become minus 50 centimeter. From this data, we have to find V2, that where final image will be formed, and V2 is distance measured from this. Okay, further using equation n2 by v upon n1 minus u is equal to n2 minus n1 upon r. So image is forming in a medium of A. So here will be refractive index n, and v is v2 minus n1. For second reflection, this object is inside the sphere, so refractive index of this object is 1.5, and object distance is considered as u2 is equal to 50 is equal to n2 minus n1 is equal to 1 minus 1.5 upon radius of curvature is minus 50. So 1 by v2 minus we can say that 150 divided by 500 is equal to minus 0.5 upon 50. Let us say minus 5 by 500. So move this term in right side. So 1 by v2 is equal to 150 by 500 minus 5 by 500. So taking LCM as 500, 150 minus 5 is equal to 145. So further simplification, V2 is equal to 500 divided by 140. So 5 into 100 upon 5 into 29. 5 into 2, 4 into 5. Okay, this is V2, and V2 can be considered as 100 divided by 29. So V2 will become 1 minute. I think we made a mistake. N2 is equal to 1, N1 is equal to 5, U is equal to 50. 1. Here 1.5, we consider 1.5 as 150. Here only 15 divided by 500. Okay, some calculation mistake here. Calculation mistake from this step. Let us calculate further. Minus, we can say that 15 divided by 500 is equal to minus 0.5 by minus 50. Minus minus cancel. So 5 divided by 500. So one small mistake can be run all answer. V2 is equal to 5 by 500 plus 15 by 500. Taking LCM as a 500, 15 plus 5 is equal to 20. 0 0 cut, so 2 by 50 is equal to 1 by 25. So V2 is equal to 25 centimeter. So distance of this point is 25 centimeter. So now we have to find from center of the sphere. So this is the distance 25 and radius of curvature is 50. So total distance from center to this is equal to let us use a second other pen so you can see. This is 50 centimeter and this is 25 centimeter. So total distance from center to this is 50 plus 25. So total distance x. I hope you will be able to see this, or let us change pen again. X is equal to 50 plus 25. So this is 75 centimeter. Okay. So now you can say that formula is easy, but lengthiness is some good. Lengthy question can be said. Next question. Statement 1. Liquid pressure is only exerted on a solid surface in contact and is exerted in between the layers of liquid. Okay, this is a true statement. Liquid pressure is only exerted on solid surface in contact and is exerted in between the layers of the liquid. Pressure are acting between layers of liquid. So this is correct. Surface tension arises due to the difference in potential energy of molecules in bulk of liquid and etc. We consider this in a theory topic over. Surface tension is the reason of potential energy. So both statement is correct. So both statement 1 and 2 is correct. Like a theoretical question. 13th question. A rod of mass small m and a length capital L is released on a rail placed in uniform magnetic field B. What will be the terminal velocity of rod? We have to find the terminal velocity of this rod. Here, this is the resistance magnetic field inside the length of this rail is L. Okay. So we have to calculate for terminal velocity of rod. What will be the terminal velocity? V naught of this rod. So after at the situation of terminal velocity, the force acting on this rod will become F net will be 0, because terminal velocity is achieved and the F net on any body is become 0. So let us draw in this diagram that mg will be F down due to changing area. Electric magnetic flux will be linked in this area and EMF will be induced. Due to EMF, current will be induced. So first of all, find the direction of current in this rod. So let us say that flux is increasing and velocity is downward direction. So all the charges on this rod are moving downward with velocity. So magnetic field is inward, velocity is downward. So using the right hand rule, we can say that velocity is downward and magnetic field is inside. So V cross V is equal to this. So positive charge will be come here and negative charge will be come here. So direction of current will be in this direction. So current will be flow in this direction. So after getting the direction of current, we will find the direction of magnetic force acting on current carrying Y. So I is going toward magnetic field inside. So I cross P will be upward. So magnetic force will acting in upward direction. So simple this rod. Magnetic force is acting upward and mg is acting downward. And if when these both forces are equal, then this rod will become achieve terminal velocity and acceleration of the rod will be 0. So magnetic force will is equal to Fb. So magnetic field force can be written as ILB is equal to mg. Now we have to find current I. So for current I, we have to find EMF produced at these two ends, and EMF is considered as motional EMF. So motional EMF E is equal to VBL. And further, EMF can be written as I into R. So VB not into L. So V naught is equal to IR upon V to L. Okay, this is our terminal velocity, and answer is given in the form of a magnetic field L mgr. Here we have to again eliminate current I. So V naught is equal to I can be written further E upon R into R upon BL. So EMF can be written as R upon EMF can be written as BBL. 1 minute, I think we have to use another equation. We have to calculate for terminal velocity in the form of BLR and mg. Okay, magnetic field is equal to mg, ILB is equal to mg, E is equal to B naught L IR. Let us put value of I in this equation. Make the subject current from here V naught V into L upon R. Let us see equation 2. Let us put equation 2 in equation 1. We will get V naught V L by R in LB is equal to mg. So V naught V square L square by R is equal to mg. So V naught is equal to mgr by V square L square. Okay, this is the terminal velocity of rod. Okay, so check the option mgr.